So the next property we're going to take a look at is something called viscosity. And viscosity is defined simply as a measure of a fluid's resistance to flow, right? And that may seem sort of counterintuitive in terms of its definition, but simply put, we can think of as the higher the viscosity of a liquid, the more slowly that liquid flows, right? So high viscosity, the more slowly it flows, and that's a direct result of the strength of the intermolecular forces that you have between the particles of a liquid. So liquids that have, we'll say higher, that's a wrong term here. Liquids that have stronger intermolecular forces have higher viscosities, right? They flow more slowly than something with a weaker intermolecular force of attraction. And as two examples here, if you think of, let's say something like glycerol, okay, glycerol is a very, very, very thick substance. It's a liquid. So we'll think of it as, we'll just say very thick. Let's say comparable to something like to syrup, okay, or honey, for instance. And if you compare that to something like water, okay, as we know, water it doesn't flow. It flows a lot easier than syrup or honey, which is what we're equating glycerol to. And what we see here is the viscosity of water. This is 1.01, and the units are Newton seconds per meter squared. You don't need to memorize these. It's just, we just need to be able to compare them. So this is 0.00101. And then in the case of glycerol, it is 1.49. Okay, so the viscosity of water is about what, 1/1000th that of the viscosity of glycerol. So we can say then water flows easier than something like glycerol, okay, which doesn't flow very well. It doesn't flow easily. It's thicker. And again, that has to do with the intermolecular forces of attraction between each of these types of molecules. So we've seen water, for example, water does have hydrogen bonding. So H bonding is present. And if you look at the structure of glycerol, glycerol is up here. Yes, we do have, just like we do in water, we have this OH, very polar bond, but we actually have three of them in glycerol. So we have more hydrogen bonding present. So we have the same type of intermolecular force. They both contain, both water and glycerol do contain hydrogen bonding, but there's more of it present between the molecules of glycerol. As a result, the particles are going to be they're going to be attracted to each other a lot more closely, a lot more strongly. They're going to stick together more, and as a result, it doesn't flow as easily as in the case of water, for example. So the other property here that contributes to the higher viscosity of glycerol is not only the greater number of hydrogen bonding places that are possible, but also the shape of the molecule as well. Glycerol is a lot bigger than water molecules, so these can actually become more entangled with each other. Okay, and water doesn't have that problem, right? Water can actually, or it doesn't become as entangled. So greater entanglement between the glycerol molecules, you have way more hydrogen bonding present. The end result of that is that your glycerol then is going to be more viscous, whereas the water is going to be less viscous. Something that is more viscous is thicker, doesn't flow as easily. Something is less viscous, is a little bit smoother, flows very easily. So one last thing to keep in mind when it comes to viscosity, and we'll see this with some of the other properties as well, is that, for example, in our table that we have here, we have these viscosities listed for several substances, and then they are listed at a particular temperature, right? So in this case, they're listed at 20 degrees Celsius because viscosity is going to be temperature dependent. And generally what you'd see is as the temperature goes up, the viscosity is actually going to go down. It becomes less viscous and it's easier. The liquid flows a lot easier. And again, you can think of as an example, if you heat up some syrup or some honey, right, it becomes more liquidy, right? It becomes more, it can flow a lot easier than if you have cold honey or cold syrup. Right? It's really, really thick when it's colder, while it's really runny when it's warmer. So viscosity does depend on temperature, and a lot of the tables that you'll see not only give you the values, but they usually specify a particular temperature at which those values are measured.